So first gravitational field. Now you can see, right, how many papers we have done this derivations everywhere. So you should learn. Work done per unit mass. And in moving this mass or a unit mass from infinity to a point within field. Okay. Now, the sphere in B is a planet with radius of this, and the planet has no atmosphere. A rock of mass directly moves from 4r to 3. Calculate the change in gravitational potential. Fine. So this is that planet. This is say 4r.
B part skip कर दिए.
B part मैंने किया नहीं. Oh, sorry. An isolated solid sphere of radius may be assumed to have mass concentrated m. The magnitude of gravitational potential surface is phi. Okay. And show that the gravitational potential center. So it should be phi, should be here at r, definitely. At 2r, it should be half. At 3r, it should be, I don't know, somewhat like 1/3 क्या होता है? I don't know. 4r पे कर लेते हैं. 4r is 0.33. Should be 0.25 is here. 0.33. 0.25 तो यहाँ होता है. 0.25, 0.33, which should be somewhere here or something. Okay. And then you make a smooth curve. Like this, right? Not too hard. Then,
sphere के अंदर.
Sphere के अंदर? What do you mean?
तो potential जो है 0 से लेकर r तक potential नहीं होगी?
0 से r तक इधर? नहीं. No, my friend. It is different.
तो अंदर नहीं होती potential.
अंदर potential जो होता है ना वो center तक 0 हो जाता है फिर से, but it has a derivation involved. That's why.
तो हम लोग center मतलब 0 to r तक कुछ भी ना.
नहीं r से उसने कहा ना r पे phi है तो r से बस phi बना देना. You don't need to draw anything else. Okay. Please do remember that.
All right, sir.
Okay, anybody has a question now?
और जैसे potential energy का जो ग्राफ होता है वो भी नेगेटिव होता है या वो हमेशा पॉजिटिव ही होगा?
Negative. Potential energy is always negative.
सही है.
Change could be positive or negative. That's something. अच्छा जैसे इसने कहा ना change in gravitational potential energy of the rock, like it is moving from 4 to r. Now it will be negative. I'm sure of it. Okay. So उसमें change में हम लिख सकते हैं. It doesn't really matter. Okay. So it is G mm over r, right? Like that. And minus. Why am I saying this? Because change in potential times mass is Gp. Okay. So Gm minus over r. This is Gm upon r. So 6.67 times 10 raised to minus 11. Mass is 6.0 times 10 raised to 24. And आज मलिका नहीं आई. What is happening in this world? 3.4 into 10 raised to 3 divided by, now there is a change in R, right? From 3R to 4R. So we are going to write, like you can, there is an R. Yep, there is an R. So 4 minus 3, and R is going to be 6.4 times 10 raised to 6. What was the answer? You guys?
1.8 times 10 power 10.
Okay, that's cool. Explain whether rock speed increases, decreases, or stay the same. It should increase, you know. So kinetic energy increases due to loss in potential energy. Gravitational potential energy, hence speed increases. Like this. Now it says a square is this. How much? Explain how the following terms equation derived from first. This is Nm over V, 100%. Total mass over total charge. 1 by 3. 1 by 3 means that it is basically depicts three-dimensional motion of molecules. So 1 by 3 is one of them. Okay, c square. That is the average speed of average speed square of randomly moving molecules at different speeds. Should be written like this. Now, calculate the,
Is
yes.
it okay to write root means square seed?
But there is no root here. It just means.
No. Okay.
Yes. Okay. Now, the mass of gas is this. Calculate the mass of one molecule. Whoa. Right. So first of all, we want to find how many molecules are there. PV equals to NKT. And K is 1.38 times 10 raised to power minus 23. Should be like this. And the temperature is 17. 17 plus 273 is 290. So N is, anybody found N?
Sir, it's 4.5 times 10 power 23.
4.5 times 10 power 23. Okay. And now this is the mass of all these particles. So one molecule will be 2.70 grams over 4.5 times 10 raised to 23. Yes. The answer is
With that, I did not do.
इसका मतलब ये गलत किया था.
नहीं सर n तक सही करा था.
Okay.
4.6 times 10 power minus 23.
So that should be the answer. Somebody please check the answers as well. All right. Now, by reference of the first law of thermodynamics, state and explain the change, if any, internal energy. Lump of solid that melts. If the solid melts, so there is there is little to none change in volume because it's just the same. Hence, work equals to 0. Sorry. Please don't write like work done, like full equals to 0, 1. For the next mark, you should write about that the heat, energy overcomes the bonds. Siri, you should write according to change in internal energy equals to Q plus W. Hence, internal energy increases.
सर वो वाला लॉ कौन सा है जिसमें बोलते हैं कि सम ऑफ काइनेटिक एनर्जी प्लस पोटेंशियल एनर्जी इज इंटरनल एनर्जी?
That is the same law.
सर तो अगर मैं उसके रेफरेंस से लिखूं तो भी सही होगा?
नहीं. Because right now we're looking at change in internal energy. We're not looking at what is the internal energy. What is internal energy? We're not defining it. Okay.
सही है सर.
Some gas in the toy balloon. When the boy balloon bursts, no thermal energy enters or leaves the gas. Right. So if this happens, then when it bursts, right? So there is increase in volume. There is a change. Okay, increase in volume. Work done by gas on atmosphere. And third, since energy is not there, right? Energy is not, so change, increase in internal energy plus 0. Q is 0, work is negative. So internal energy decreases. Like this. So you should always bring first law of thermodynamics and learn, relate it to that. Okay, then should I go forward then? Okay, so dish, super easy, super easy. Use figure this to show angular oscillation. This is 2.9. So I think what is this? This is not fair. I hate it when they give it something like this, you know. I have to calculate.
2.2 है, 2.2 है.
2.2. हाँ, चलो ठीक है. You say it. So omega is 2 pi by 2.2. And the answer is, it should be 2.9. Right?
Yeah, sir, it is.
Can't be wrong on that. Use the answer to determine R. So we have the equation here, which should be equal to minus omega square R. So GR minus, or omega square equals to GR. Oh, this is not even the part. Omega square equals to G upon R. So R will be, this is capital R. Okay. R is going to be 2.9 whole square over 9.81. Okay. Go on.
So would it be 9.81 over omega squared?
Yeah. Sorry, my bad.
So I think it's 1.2.
1. Okay. Then says calculate the speed of the ball as it passes through the center. So kinetic energy, it will have maximum energy at that point. V naught equals to, this is the R, right? V naught equals to, नहीं ये नहीं है, x naught निकालना पड़ेगा, omega x naught. 2.9 and x naught, maximum displacement is 3. Yep. 3 into 10 raised to minus 2. Yes. Now what you do? What you get?
0.087.
0.087.
सर अगर
And
मैं वो cos और sin वाली equations यूज करूं
नहीं कर सकते ना.
क्यों सर?
First, we don't have the equation for this. Well, you can make one. You're right. You can make one.
सर मैंने यूज करी थी लेकिन मेरा फाइनल आंसर गलत आ रहा था. मुझे याद नहीं रहा था वो v नॉट इक्वल्स ओमेगा x नॉट.
हाँ, ये बनेगी ना equation. X equals to 3. I mean 0.03 cos 2.92. ये बनेगी equation. I think. फिर वो बड़ा मस्त.
डिफरेंशिएट करना पड़ेगा.
Then you have to differentiate, and then you have to put the time. I mean, for at maximum, so it is going to be very long. So don't do it. As some moisture contacts the surface dish, so becomes lightly damped. Okay. So it should be like here, and after like every oscillation should lose some of the like this, but the thing is that it will always have the same frequency. Then explain detection. Okay, so detection of ultrasound. Now, well, number one, pulse of ultrasound. Okay, get reducing. बल्कि यहाँ पे लिखो reflected pulse. Reflected pulse of ultrasound. ठीक है. Incident on piezoelectric crystal. You can also write quartz crystal. Third, crystal is made to oscillate. And fourth would be that this causes EMF to be generated across the crystal. So that should be detection. Okay. Now, by reference to specific acoustic impedance, explain why there is a very little transmission of ultrasound from air to skin. So this is the same thing. So large difference in air and skin. So reflection is almost equal to 1, right? So you should write that. Okay. Small difference in Z1 and Z2 is nearly 0. So most of the pulses are reflected back into air without transmitting. So you should remember this, right? Now, any questions? Please let me know. 6, telephone signals are not there anymore. All right, electric fields. Now, what is meant by electric field strength? Electric field strength for 2 marks is force per unit charge on a positive charge. So it is very important. This is 1 mark, this is 2nd mark. Then determine the radius of the sphere, explain your working. So radius of the sphere would be right here. I think it is 4.2.
4.5.
Okay, yeah, 4.5. That is correct. My bad. So it should be 4.5. How do you, by the way, to explain the working, you should have the line drawn, okay? So you could also say that, this is 0. Electric field strength is 0 inside. You can also write it. Let me write it. Electric field strength is always 0 inside. Okay, determine the charge on the sphere. E is equal to kq over r square. Electric field strength at that point. What is this? 1678.
18.
Nice. So 18, and there should be something else as well. 10 raised to a 5.
Sir, is it okay to take the 17.5?
No, that's wrong. It's clearly 18, Lisa. How could you read 17.5? It's time to put you back to kg, I think.
But certain the whole question would be wrong.
No, still the whole question is wrong. What is the answer now? Tell me.
4.05 times 10 power minus 7.
10 raised to minus 7. Okay. Now, an alpha particle situated distance d from center, calculate the acceleration. So, alpha particle situated 8 centimeters center of sphere. 8 centimeter from the center of sphere. Somewhere right here. Let's go here. Up now it is in the middle, Lisa. So, I don't know. It's 6, 5.5, and 6. Can we take 5.75 then? Exact middle. So electric field strength is 5.75 times 10 raised to 5. So what you need is, we need acceleration. Okay, F equals to EQ, MA equals to EQ, A equals to F upon Q over M. So it is an alpha particle. Do we have the force? We don't have the force. Sorry, this is EQ. So this is 5.75 times 10 raised to 5. The charge on it is alpha particle, which is 2 times 1.6 times 10 raised to minus 19. And the mass of alpha particle is 4 times 1.66 times 10 raised to minus 27. Can you find A?
तो फोर्स निकाल नहीं सकते k q q over r square से.
क्यों निकालना? क्या फायदा होगा इससे? टाइम वेस्ट करने के अलावा क्या होगा? मुझे बताओ.
यही बात है.
So we are opting for smart work. Yes, and the answer is
तो ये क्या है 10 power पहला वाला
10 power 5. How many people could do this?
फिर मैंने एक गलती कर दी थी, मैंने 8 सेंटीमीटर नहीं, मैंने 4 सेंटीमीटर लिया था शायद.
Nahil, Lisa, Ida. Okay.
सर
No,
ये आ रहा
I
है
cannot do this.
Okay, what is
2.77 times 10 power 13.
2.77 times 10 power 13? Okay. So please let me know if you have a question now. ये इसी तरह के अब question आएंगे. Because whole electric
Sir?
field is, yes, Lisa.
Is it okay to round it off to 2.8 10 to the power 13?
Yes, that would be ideal.
Thank you.
Okay, ideal op amp, not there. Over the weekend, I'm going to give you a worksheet that I made for, the other things. What are they called? Sorry. Wait a second. I made the worksheet for astrophysics, so I'll give it on to you on weekend, and then I'll check it. So that chapter is covered as well. Second, I need to put in the charger. Okay.
Sir, can I ask a random question?
No, Lisa. After this.
All right.
Okay, because this is a recorded session, your random question will also go into the recorded session. Now, the path of the electron in the magnetic field is an arc of circle radius 6.4. Explain the direction of magnetic field. Now, this is an electron, right? So I can see that there is a force here and the velocity here. So right now, whether you use for electron, for anything negative, for negative, use right hand Fleming. For positive current or charge or whatever, you use left hand. So you just switch the hand. So from the right hand, your thumb should be here. Your middle finger should be, your middle finger should be towards V. Okay. So your index finger, you notice that it's going into the pitch. So we are going to basically just say, acha, in the answer now, when they're saying, please let me know where that is. So remember that you will write Fleming according to Fleming's left hand rule. Acha, why do we want to write this? Because there was never a right hand rule. The thing is that what you do, you take left for the positive. So for the left, you use it, and your answer for this will be out of the plane. But that is only true for positive. So you switch the direction. So if your left is showing you out, so in reality for an electron, it will be into the page like that, right? So according to left-hand rule, right, force is perpendicular to direction of velocity. Hence, field is into the plane, like that. I hope you guys understand this, right? Now it says show that the speed of electron is this. Okay, we have magnetic field strength. What else do we have? We have the charge. And we have the radius. Okay. R equals to mv over bq. 6.4 minus 2. Mass of an electron is this. I hope you guys remember this. I mean, it's already there. No need to remember. It's 8.10 raised to minus 4. And charge of electron is 1.6 times. So the answer is, I think it should be the correct answer. I don't see any mistakes, but you can still check.
तो ये इक्वेशन याद होनी चाहिए या FC इक्वल्स FB करके ड्राइव करने कोई मसला नहीं है?
कर लो तो ये फिर मैं तुम्हें कहूंगा why would you reinvent the wheel all the time when you know it is there?
तो याद नहीं है ना इसलिए।
सर मैंने तो ट्राई किया।
आपने ट्राई किया था reinvent
Yeah.
करना? Okay, and then
I got 8.99 10 to the power 6.
that's cool. Very nice. So you can try it. You know that it is mv square over r equals to bqv. You can do this. Fine. Okay, then it says uniform electric field applied to the same region. The electron passes undeviated. Fine. Mark an arrow direction electric field. Now the magnetic field was trying to force it down. So electric field will be upwards. So you just need to do electric. Now use the data to calculate the magnitude of electric field strength. Very, very easy. If you remember this formula, that's cool. If you don't remember this formula, so you write VVQ equals to EQ. Q and Q cancel out. It will be like this. Now, V we already have 9.0 times 10 raised to 6. Electric field strength is what we need. And the magnetic field is 8.0 times 10 raised to -4, I believe. So electric field is yes, please.
7200.
7200.
Yeah, same.
Very good. Now the electron is now replaced by alpha particle moving. Describe and explain the shape. Undeviated. Because velocity is independent of mass. If you look at it, it's like, velocity is dependent on E and B. E is what? Force upon charge, and B is what? Force upon VQ, right? Like that. So basically, if you check it out, there is no mass in it. No mass. It's independent. So you got to write it like this. Now state the Faraday's law of electromagnetic induction. Induced EMF is directly proportional to rate of change of magnetic flux linkage. It's like that, okay? And then state one function.
Sir, what if we do not like linkage?
Linkage, no worries. It's fine.
Hmm.
Okay, state one function of transformer. So the function of transformer is to step up or step down voltage. You can also write change. Now, sinusoidal alternating current in primary coil gives rise to magnetic flux linking this. Use Faraday to explain why output from transformer EMF that is alternating. Oh, okay. Number one, magnitude varies, right? Of what? That's important. Of rate of change of flux. Then what happens? Direction of EMF varies. Changes due to change in flux, due to change change in direction of flux linkage. That could be one. How many marks? 3 marks. And third, so constantly changing flux causes EMF to switch direction as well. Now, state why soft iron core is laminated to reduce eddy currents that cause loss of magnetic flux in the core. So you can write it like this. Okay, what is this? Valence band is not there anymore. Good thing. Okay, this is, however, there. The structure of copper to be examined using electron diffraction. Electrons having accelerated through this, okay, de Broglie wavelength, calculate the accelerating potential difference. Oh, interesting. Lambda is equal to h over p. Okay. All right. Well, either you can use this or you can, I mean, yeah, okay, this will take time. So h over mv, what is this? This is electron, right? So we can find this. 6.63 times 10 raised to minus 34 divided by lambda is 2.6 times 10 raised to minus 11 and the mass is 9.11 times 10 raised to minus 31. Can you find the speed, please?
0.799 times 10 power 7.
0.799.
2.8. 2.8 times 10 power 7.
Okay, so this is the answer for V, and we need to find the potential. So electric field, energy provided by electric field is this, equals to half mv squared. We need V. Half times 9.11. This will be 2.8 divided by, now
5.7 times 10 power minus, 2230.
13. Well, you should not write it like this. You should write 2200. Okay, volts. Now, question number 12. If you guys are stuck at any point, please do let me know. What is meant by the mass defect of the nucleus? Mass defect of the nucleus means that this is the difference between a bound nucleus mass and its mass of constituents. Okay. Where this is 1 mark and the second mark I'll write it here. Where they could be separated to infinity. Okay, now this is this, and now they have shown that show this. Now, E equals to mc square. Whenever do this, go through the sparks. 1U is 1.66 times 10 raised to minus 27, and this is 3.0 times 10 raised to 8 whole square. Can you find the energy, please?
.494 times 10 power minus 10.
Sorry, come again.
1.5 times 10 to the power of minus 10.
Joules. Okay. Now what you do? 1 EV equals to, हमने किसमें देनी है? MEV में, sorry, 1 MEV equals to 1.6 times 10 raised to minus 30 joules. So we divide this. What do you get?
So it's 934.
933.7.
930. Why 933?
Yeah, 0.75.
Okay, proved.
0.75.
934. Okay, proved. Now, binding energy per nucleon of helium is this, per nucleon. Okay, we could do that. Helium is this much, as you can see, and its constituent is this. So it is 2 protons and 2 neutrons, as I can see. So if I multiply by 2, what will be the mass? Go on.
So I didn't do that. I just did it directly.
That's wrong.
Why, sir?
I could be correct. I'm sorry. Can you do it now?
Sir, it's 2.01455
2.01
4552.
That's correct. Okay. Then multiply this by 2.
2.01733.
733. Is that correct?
Yeah.
Okay. Now the mass of constituents is going to be, you add them. What is the answer then?
4.0318.
4.0318.
82.
Okay. 3182. Okay. Yes.
No, like 31882.
882. Okay. So if something goes wrong, blame Lisa, please. And now the mass defect is going to be for constituents minus sorry, I got disconnected for some reason. I don't know why. This will stop other screen sharing. Yes, of course. I don't want to. Okay, you guys can see? Hello?
Yes, sir.
Okay.
Yes, sir.
So when you subtract them, you get change in mass. What is that?
0.030376.
0.00.
No, 0.030376.
Okay. Okay, Lisa. Thank you, Lisa. Now when we get U, so we know 1 U is 934. So 0.030376 U is how much? You just cross multiply. Okay. So when you multiply, no, do you? Yeah, you cross multiply.
Sir, don't we have to convert them to kg?
No, nothing. Because you already have this. So you can directly do it. So can you multiply?
It is 7.09. No, it is 28.37.
28.37 MeV, right? And then you divide by 4 because there are 4 nucleons in it. And then what you get? 7.09. Do you guys understand this? Like that. Pretty
That's pretty easy.
Yes, it is pretty easy, Lisa. Why did you get it wrong then?
No, I got it correct actually.
Okay, that's cool. Now, isotopes of hydrogen have binding energies per nucleon more than 3. Says why nucleus does not spontaneously break down to become nuclear hydrogen. Because there is a huge difference, right? Large difference in binding energy per nucleon. So, large amount of energy is needed to break or separate nucleons of helium. Is it clear?
तो ये लिख सकते हैं कि helium-4 is more stable than hydrogen.
Sorry, come again. I was busy somewhere. Yes.
तो
Come
मैं कह
again.
रहा हूँ कि एनर्जी के बजाय हम लोग ये लिख सकते हैं कि helium-4 is more stable than hydrogen.
Yes, you can. I think write that. You can write that.
All right, sir.
Okay. So that is the end. Yay! So you guys have any questions in this? Please let me know.
Answer question 9.